We've now wrapped up our initial overview of the elements in Java streams, focusing primarily on how the intermediate and terminal operations work. I gave you a chance to also learn a bit more about how iteration works. And what we're going to do now is we're going to continue our discussion about how things work by starting to look at the internals of how streams operates under the hood. And there's a bunch of different reasons to look at this, not the least of which is it's just very cool. And it'll also give you a sense of what parts of Java streams you can customize as an application developer and what parts you can't. And knowing what you can customize and what you can't is very important because it'll give you a sense of where it's worth trying to exert additional effort, for example, to speed up your program or to introduce new types of data structures that'll serve as sources for streams, as well as perhaps different ways of collecting the results up into a final reduced result. So if you recall, a Java stream consists of 3 phases, which are described in the link at the bottom of the slide. The first phase is the split phase, where it uses a mechanism called a spliterator. It's actually part of a framework called a spliterator that converts a data source into a stream. Then there's the apply phase that processes the elements in the stream. For sequential streams, those of course are all done in one thread. For parallel streams, they're split up into chunks and processed by different threads in the common fork join pool. And that, of course, is going to give you a big speed up if you have the right conditions, like lots of elements to process and lots of processing per element, because those can be mapped to the underlying processor cores. And that's really, of course, the secret sauce behind parallel streams is getting that kind of a speed up. And then the third and the final phase in the streams pipeline is the combine phase, where the intermediate operations are all triggered and they run either sequentially or in parallel, and a single reduced result is created, either by reduce or collect or something else like the for each method. And knowing which of these phases you can control, and perhaps more importantly, once you know that you can control them, how to control them is very important, especially if you start doing things that are slightly off the beaten track with the streams framework, which is designed to be extensible and customizable. Right now, in this discussion about internals, we're going to focus pretty much extensively or exclusively on sequential streams. And then later, when we get into the parallel streams discussion, we'll start talking about how streams works internally there. It's actually not that different from a code point of view, but of course, the behavior is quite different. So let's first start by talking about mechanisms in Java streams for splitting and combining things. So that's basically bookending the beginning and the end of a stream. Now, the splitting and combining mechanisms are often invisible, and that's intentional. The idea is if you can use what comes out of the box, do so, you have a lot less work on your behalf. You don't have to do as much code. So I tend to think of these things as kind of like being ninjas, where you don't see them when they don't want to be seen. So for example, all Java collections you get out of the box with the Java development kit in the Java class library come with predefined spliterators. And if you take a look at the interface for collection, which of course is what all the collections inherit from, except for maps, but we'll talk about that later, you'll see that they have a spliterator factory method that's used to create a spliterator from the collection, and there's all kinds of different ways to do that. And then you'll also see that spliterator method is used in some of the factory methods, like the stream and parallel stream factory method. So those are what are used to actually split things up and start the ball rolling. At the other end of the spectrum, at the end of the stream, in the terminal operation phase, Java also defines a collectors utility class that has a bunch of collector factory methods that are used to make collectors for common data types. So for example, if you take a look there, you'll see that there are factory methods like toList, which makes an array list. There's a factory method like toSet that makes a hash set. There's toMap that makes a hash map, and so on and so forth. And these are what are used to actually create the collections that are collected into by collect, if that makes any sense. And we'll talk more about those things in a second. Now, all this stuff comes out of the box. For the vast majority of use cases, you can use what you get But the cool part is you can also come along if and when you need and customize these behaviors to perform user-defined splitting and combining. How is that possible, you might ask? Well, it turns out that there's a splitterator interface that's defined, and you've now had a chance to implement some of the methods in it. And this interface is used to traverse and partition the elements of a source of data. And as we saw, there's try advance, try split, and some other methods as well. There's also a collector interface, which is how collectors are defined. And you can see that this collector interface has a bunch of factory methods like supplier, accumulator, combiner, finisher, and so on. And these methods are called by the streams framework automatically in order to create what's called a mutable result container that's appropriate to be able to consolidate and combine the elements of the stream into a final reduced result. So once again, the framework is defined for you. Now, of course, Java uses these frameworks. It uses the mechanisms we talked about here with Spliterator. It uses the mechanism we talked about here with the collector, and it comes with a bunch of predefined things. But because these are defined as publicly available classes, you can come along and create your own Spliterators. You can come along and create your own collectors for various good effects, as we will see here shortly. So that's just a quick overview of splitting and combining. We will cover splitting and combining in much more detail here shortly, but I want to give you kind of the big picture view first before we dive into the details of how to apply these mechanisms in practice.